Welcome to video on cryptocurrency concept, decentralization, and consensus mechanisms. In this session, we dive into a fundamental question at the heart of decentralized digital currencies. How do these systems agree on which transactions are valid when there's no single central authority directing the process? Imagine a group of friends trying to decide where to eat for dinner. No one person gets to call the shots. Instead, they hold a vote, and the majority rules decide the restaurant. This simple notion of collective decision-making mirrors the way consensus works in cryptocurrencies. Here, instead of relying on a centralized bank or institution, the entire network of participants agrees on the state of transactions through protocols that interweave technology and incentive. Before we explore the specific methods, it's crucial to appreciate the broader idea of decentralization. In traditional financial systems, a central authority such as a bank or government has the ultimate say in verifying and recording transactions. But what happens if that central authority is compromised? For instance, think about a scenario where a bank's main server is attacked and all client data is at risk. One breach can disrupt the entire system. Cryptocurrency solved this problem by operating on decentralized networks. Every participant, or node, in the network holds an identical copy of the transaction ledger. This way, even if one node fails, many others continue to uphold the system, eliminating any single point of failure. Let's start by examining proof of work POW, arguably the pioneer of consensus protocols in the digital currency realm. In a POW system, every transaction is validated by solving intricate mathematical puzzles, a bit like being in a competitive game where every participant, known as a miner, races to solve a complex riddle. Imagine a giant puzzle contest where the first competitor to complete the puzzle wins a prize. In this context, the winning miner earns the right to add a new block of transactions to the blockchain and is rewarded with newly minted coins. This design inherently ties validation to the expenditure of computational resources. The more processing power a miner brings to the table, similar to having more puzzle-solving skills or faster computers, the higher their chances of solving the puzzle before others. Picture an intense race where every contestant's progress is visible to the entire community, ensuring fairness through constant verification. Additionally, altering a block would require redoing the complex work for that block, and all blocks that follow a task as impractical as trying to overturn every decision made in an entire tournament after the final whistle. This security feature makes POW robust, though it does come at the cost of significant energy consumption, a debate in its own right, with comparisons often drawn to the energy usage of small countries. Now, let's shift to our next key consensus mechanism, proof of stake POS. Unlike proof of work, where solving puzzles is the basis for validation, proof of stake selects validators based on the amount of cryptocurrency they hold and are willing to stake or lock up in the network. Think of POS like a voting system among friends where your vote's weight is determined by how much you've invested in the decision. If you've put money on the line by staking your coins, you have a stronger influence on the outcome, just as someone who has contributed more to a communal fund might have a larger say in how it's spent. In a POS system, validators are chosen to create new blocks and confirm transactions based on the proportion of their staked cryptocurrency. This method is highly efficient because it slashes the need for massive computational power. Consider a scenario where instead of running an endless marathon race as in POW, everyone sits around the table, and the weight of each vote is proportional to their investment. This built-in incentive ensures that validators have much to lose if they act dishonestly. For instance, if someone tries to manipulate the system, most POS mechanisms implement a slashing penalty where a portion of the stake coins is forfeited, thus economically penalizing fraudulent behavior. Both proof of work and proof of stake ultimately serve the same purpose, ensuring every transaction recorded on the blockchain is valid, accomplished without a centralized intermediary. The beauty of these mechanisms lies in their ability to create trust on what is called a trustless network, trust not given by a single entity, but built through distributed verification. Imagine playing a game where every move is recorded by an impartial system that everyone can check. This inspires confidence that the rules are followed, and the outcome is fair. While POW and POS are the most widely known consensus mechanisms, they are not the only options available. Some networks experiment with hybrid models or alternative approaches like delegated proof of stake (DPoS). In DPoS, stakeholders vote for a small, trusted group of delegates to manage consensus on their behalf. Picture a company where the board of directors is elected by the shareholders. The more you invest, the greater your influence in selecting these decision makers. This variation balances efficiency with involvement, giving networks flexibility in how transactions are validated. In our discussion today, notice how consensus is achieved through an interconnected process where every node plays a role. In a decentralized network, no single entity can choose which transactions are included in the ledger. Instead, it's akin to a computerized process where every participant checks, verifies, and then agrees on the next block of transactions. This process is not only democratic but also extraordinarily resilient. Even if several nodes fail or try to introduce false data, the remaining nodes uphold the integrity of the system like vigilant jurors ensuring a fair verdict in a trial. Beyond digital currencies, the implications of these consensus mechanisms are vast. The same concepts can be applied to manage secure supply chain verification or even digital identity management. Picture a supply chain where every step from the origin of raw materials to the delivery of finished goods is recorded permanently on an immutable ledger. This ensures that all participants, from the manufacturer to the consumer, are confident in the product's integrity and history. To sum up, today's exploration unraveled how decentralized networks validate transactions without centralized control. We looked at proof of work, where computational puzzles foster a competitive and secure environment, and proof of stake, where validators' financial commitment ensures an economy of trust and responsibility. Both methods merge economic incentive with technological security, creating a system where every block added to the chain is a testament to collective consensus. As you reflect on these concepts, consider the elegance behind these mechanisms. They are not merely technical tools, they are the underlying principles that redefine trust for our digital age. Like a well-organized group of friends making collective decisions, these protocols ensure that every participant's contribution is valued, every malicious act is penalized, and ultimately, that the entire network prospers through shared security.